Welcome back to day 8 of our Python Masterclass. So far we have learned how to store and manipulate data using variables and different data structures that are lists, tuples, dictionaries and sets, so many. But there's a question that what happens to our data after the program ends? If we only store data in the variables, everything disappears once the program stops. So to solve this problem, Python provides file handling, which allows us to save data permanently. So we'll also learn exception handling, which helps our program handle errors gracefully instead of crashing. And so by the end of this class, you'll know how to work with files and write programs that are more reliable. Now, let's imagine you're creating a student management system. So, you enter the student's name, marks, and the roll number, everything works perfectly. But when you close the program and open it again, all the data is gone. So, because variables store data only in RAM, which is a temporary memory. So, if we want to keep data permanently, we need to save it in a file on our computer. So, this process is called as file handling. So using file handling, we can read information from files, write new information and update the existing data. And real world example include saving student records, customer details, reports, invoices and application logs. Now opening files. Before we can read or write data, we first need to open the data. So Python provides the open function for this purpose. When opening a data, we usually specify the name, the file name or the path and the mode, which tells Python that what we want to do with that file. So once we are done, it's important to close the file also. Closing a file frees system resources and ensures that all the data is properly saved. Later, we will also learn a better approach using the uh, with statement, which closes the file automatically. We will practically discuss this in VS Code after completing the whole theory part. Like that will be simple, and like instead of skipping VS Code and then to the theory part. So at the end we will practice questions. So now, when opening a file, we must tell Python how we want to use it. So this is called as the file mode. If you write R, then reading the file, W writing the file, we have A, X, RB and WB also. So choosing the right mode, it's very important because it determines what operations we can perform. We will check all these uh, in the practical practice in the last practice session. And reading file, for this read, it reads the entire file. Read line, only one line at a time, or read lines, all the lines, and stores them in a list. It reads all them. Then each method has its own cases. If the file is very large, then reading it line by line is usually more efficient than loading everything into the memory at once. So we'll compare all the three methods in the VS Code later. Actually, this whole thing, we can just quickly end up this theory part, and we'll focus more on the practical part, as you'll be uh, you'll you won't understand just by this theory part. Once we start practical, then you'll be understanding how to open, read and all. Then besides the reading files, we can also write our information also. So it the write method that adds the new content to the file. So if the file is opened in this write mode, then the old content is removed before the new content will be new, before this new content is added. So if we don't want to lose this existing data, then we have to use the append mode. So appending simply adds new information at the end of the file instead of rewriting the old information we have. So this is useful for maintaining the logs, like history logs, call logs, attendance records or daily reports also. So closing files and with statements. Whenever we open a file, we should also close it. So closing a file ensures that all the changes that we did are saved properly and it releases the system resources. So however, beginners often forget to call the close. So to avoid this problem, Python provides the with statement, when we use this with statement, the with open, then Python automatically closes the file after we are done with it. Like it automatically closes that file by using this with open. So this makes our code cleaner, safer, and it is considered the best practice. Now we'll see the real world applications. So I guess you already have understood file handling is almost used in many software applications, like saving student records. You like everything, read, write, close, append, everything is necessary there. Generating bills in the shopping applications, maintaining attendance records, storing customer information, or saving the game progress. As you can see, like if you uh, like for people who play games, like even after 1 month, you open the game again, so you can see the progress and you will start from the next part. So that's where this file handling is used. So without file handling, applications wouldn't be able to remember the information after they are closed. Like if you open any application or game or anything after so many months, even years, still these by using this file handling, it will remember the previous information without deleting any data. So before going to exceptional handling, we will solve some problems related to this file handling, how to open, close, and everything. So okay, here we will create a file for this file handling. We will discuss a few questions which includes all our concepts that we studied till now. The first question is, you just listen to the question and see what I'm doing, and after that I will explain every code. Then later you can practice your own code. First, okay, fine. You have to create a file and write the data. You have to create the file name should be student.txt and txt, and you have to write your name, age, and course. So I guess it's simple. File open, and then you have to give the name as student.txt, and then we are giving w here. I'll explain you. And then file write, then name, then Tejasri, and then you know what is backslash and that, and what that does, it gives a new line. Then age, and then file dot write, and then course Python, and then file, and then close, and then print data written successfully. Okay, so here the thing is, in this program we are learning how to create a file and write data into it. The open function that is used to open a file, and the first parameter is the file name, and the second parameter is the mode. Since we have used w, which stands for write mode, if the file doesn't exist, the Python automatically creates it, and if it already exists, then all the previous contents, they are erased before writing this new data. So next we use this write method to store the text inside the file, and notice that we have this backslash and at the end of each line this represents a new line, so each piece of the information appears on a separate line. So now once we have finished the writing, it's very important to call close also. Like closing this file saves all the changes and it releases the resources that are used by the Python. And finally we print a success message on the screen. So this is the simplest example of creating and writing data into a file like this. And see, we got the data written successfully. That means our file is created. Just check where the file is created. See here, there's a file created, student.txt. See, we have our information, that is our name, age, course and all. See, now we will do one more question. I guess hope you understand this first question. Now second question is, you have to read the entire file. So we'll take a file, open student.txt and then r and then data, the file, and read, and then print data, and then file and close. So this is our code, what it says. So this says how to read data from a file. So this time the mode here we used is R, which stands for read mode. So if this file exists, the given file, the student.txt exists, then the Python opens it and it allows us to read its contents. The read function reads the complete file from the beginning to the end, and it stores it in a variable that is called data here, and then we simply print the data here. Finally here we close the file. One more thing to remember is that if this file doesn't exist, then the Python will raise a file not found error. So this method is useful when we want the entire contents of the file at once. Now we will just run the code. See, whatever content we have in this student.txt, we got our entire content here. Okay, we will write something like, my name is this and I'm studying Python, and then we'll come here to our file handling and we'll run the code. See, you have written some additional text here, but still you couldn't find that additional text when we are reading our file. It's because here you closed the file, so any changes you make in this file after file closing, nothing will be added, nothing will be updated in the existing file. It stays as it is with all the data that we have given before closing our file. So this is how it works. And okay, if we see that if this file doesn't exist, see, it says that error, no such file or directory, student.txt exists. So only student.txt exists here, so that gives the data inside it. Now we'll see our third question, that is read the file line by line. Now we'll copy this statement here, and then for line in file, print line dot strip and file close. That's it. So now we'll see what happens here. See, we got our information, but what why is this code needed? This code needed when instead of reading the whole file together, we can read it line by line. So here the file itself acts as an iterable object here, and the for loop automatically reads one line at a time, and the variable line, it stores each line here. It stores each line here, and we are using this strip because every line already ends with a new line character. So without this strip, Python prints an extra blank line here. So this approach is better for larger files because it uses very less memory than the read. It does the same thing, but it uses the less memory than our read function. For example, if we don't write this strip, you can see it leaves a space after every line here. So that's why we need to use our strip. So then it doesn't give an extra line, and it is more useful than read because it uses very less memory. So that is the use of this. Then the next question is appender data. We already read this term, that is append data. We'll write this code and see what this code says. File write college LPU. Then we'll close our file, and then we will also print that the data appended successfully. That's it. I will run the code. Okay, we saw this thing that data appended successfully. We will go and check in this txt file. Okay, wait. So this mode A, it stands for append. This is called as append mode. Then unlike the write mode, the append mode never removes this existing data. Like instead, Python moves the cursor to the end of the file and adds the new content there. So here we are adding this college name. If the file doesn't exist, then this append mode also creates it. And after writing, we close the title. We close that file, and then append mode is useful for adding the logs, records, or user information without losing the previous data. So here, I don't know why is this happening. Just close. Here we can see first we have to close and open this file again. So now you can see that this college LPO has been added to this. So if you write R here, then it removes the let me show you. If you write R, okay, sorry, it's not right. I mean to say that if you write R there, then it will add this data, but it will erase the past data also. But if you use A, then it just adds this data to the end of your previous data. So that's why it's helpful. Next question is count the characters, words, and the lines. Like we'll write the code and then we'll understand what this question means. Student.txt in R mode, and a variable data will now read here, and we need characters, words, and lines. So characters here, and we need words, that is data dot split. Then we need lines here, len data, and split with \n so that we can know the lines, and then print characters equals to characters, and print words are the words and parent lines here the line, sorry, lines. Then we'll run the code and check what happens. So it says that how many characters are there, how many words are there, and how many lines are there in our file here. Like in this program, we are analyzing the contents of a file. First, we read the entire file here, so it's in the R mode. And next, to count the characters, we simply use the length function. To count the words, we will use the split, so which divides the text wherever the space occurs, right? So wherever the space occurs, it counts a word. So that's how we can count the word. And for the length, wherever we have the backslash n, those many lines are present. So in that way, it will count the characters, words, and lines, and at the end we printed those. So yeah, now this is like a common interview question these days, and it's very helpful and useful in text processing applications also. Next, we'll go to our next question that says copying one file to another. Okay, we'll write a code. We'll take source first, and that says student.txt, and we'll take in R mode, and we'll take data. This is source dot read, and then we will close right, we'll close this file, and then destination, open, we'll say a backup text file, we'll write it, and then destination, write the data, and destination, that we'll close that, and then at the end we'll print that the file copied successfully. We'll run the code. We can check here, we got a backup text file also. So I'll explain what all we have done now. First, this program copies one file to the another. And first we open the source file in the read mode. We read all its contents and we'll store them in a variable. And after closing that source file, we open another file in the write mode, and then we write the copied data into this new file. We named that as destination file, and at the end we will close that destination file, and now both files contain exactly the same information. So this technique is commonly used while creating backups. So in student file, we have all this content. We'll check the content in the backup file. See, we have the same content in the backup file. We successfully copied our file from one place to another destination. So we can, next question, this variant is like, we have to check whether the file exists or not. So okay, we are using some different method here. I'll write the code and then I'll explain it. Import OS, and if this OS dot path dot exists, then student dot txt, and I have to print that file exists here, then else I have to print file does not exist. Just run this. See, I'll explain you this code. Sometimes we don't know whether a file is present or not. Here we know that student existing, but yeah, this OS model OS module, it provides many operating system related functions. Here we are using os.path.exists. So if the exists, so the if the file is available, then it returns true. Otherwise, it returns false. And here, this helps us to avoid the errors before opening a file, and it checks whether that file existence is considered if this file is present or not. So yeah, this helps that uh, to check beforehand and to avoid errors. So checking this file existence, it's considered as a good programming practice. Here's how we will check whether a file is present or not. We'll go to our next question, that says rename and delete a file. You can use the same thing. Import os dot rename student.txt to what should we details. We can add details.txt here, then print the file renamed, and also os dot remove details.txt, and then print that file deleted. See here, we are renaming it and then we are deleting it. See, file renamed. See, file renamed. Again, we will. Okay, we can't undo this, but yeah. Okay, 1 second. So many things will happen at a time now. Yeah, here we again got our file back into the game again. So now we'll comment this out. Now you can check in fraction of seconds, it renames and it gets deleted. Check here the students.txt, it will rename and it gets deleted so quickly. You can just comment this out and then run again. Okay, sorry, like for that you have to add the file again. Now we won't remove it. We got to know that it will get removed after writing that remove statement. We'll just see how to rename. See, this got renamed to details of txt. So yeah, this rename function, it changes the existing file name, and the remove, it permanently removes, as we have seen now. So be careful while using this remove, because once the file got deleted, it cannot be recovered. Since we have the previous code, so we got that file again and we are doing this, but once you deleted that file, you can never get back the file again, because this Python deletes it permanently. So just be careful while removing anything. So once you remove, it permanently deletes from that file from the system. So just be careful before using this remove. And once it's deleted, you cannot recover again. So just be careful before removing. And we'll see our next question. Okay, exceptional handling is in the next part. Okay, we'll use with open. With open student dot txt r as file data, it's file dot read, and I mean this file data. Okay, that's the error there. Print the data and then print file closed automatically. See, it obviously creates no, we don't have that file here. Okay, wait, we'll write here details.txt. So, oh yeah, here you can see the content there. The file doesn't exist, right? So yeah, because we renamed it to details, so now I read the file here, all the content, and then it said that the file closed automatically. It closed automatically because we used that with open. Like with statement, it automatically manages our files. Inside the block we can read or write data, and the biggest advantage is that we don't need to call that close manually. As soon as the block ends, the Python automatically closes that file without even if an error occurs, still it closes automatically, because we are using that with statement here, and this makes the code shorter, cleaner, and safer. And so that's why professional Python developers, they prefer using with open whenever possible. So that's it. Practice many more questions. These are the main things, the main parts. So you can practice more questions related to this concept. Now we'll move back to our theory part about exceptional handling. So now we'll see what is this exception handling. Now let's move to this. An exception, it's an error that occurs while the program is running. For example, dividing a number by 0, entering the text where a number is expected, and trying to open a file that does not exist. So if we don't handle these errors, the program stops immediately. And exceptional handling allows us to catch these errors and respond to them gracefully, making our programs more user friendly and more reliable. Like, what is this? Try and accept. The most basic way to handle exceptions is in Python is by using this try and accept. The code that might cause an error is placed inside the try block, and if an error occurs, the Python immediately jumps to that accept block instead of crashing this program. Like, for example, if a user accidentally enters some invalid input, and we can display a helpful message rather than showing a confusing error to them. Like, this improves the overall user experience and makes our applications much more robust, and it improves the overall user experience by using this method. And so far we have learned about try and accept, but this Python gives us two more blocks that make exception handling even more powerful, that is else and finally. The else block runs only if no exception occurs in the try block. Now think of it as saying everything went well, so now continue with this code. So the finally block, it's a special because it always executes whether an exception occurs or not. Like, this is very useful for tasks like closing the files, disconnecting from a database, or releasing some resources. And a simple way to remember is try All these four are try code that might cause an error. For that we will use try, and uh, it runs if an error occurs. We will use except, and else will runs if no error occurs, and finally it will always runs. So some common Python exceptions are these. So zero division error, it occurs when we divide a number by zero. Value error, when the value entered is of the correct type but not in the expected format. For example, converting ABC into an integer. We can't convert ABC into an integer, right? So that's the value error. Then type error, when we perform an operation on different data types, like incompatible data types. And what is an index error? It happens when we access an invalid index in a list or a tuple. Key error, it occurs when we try to access a key that does not exist in the dictionary. And file not found error happens when Python cannot find the file we are trying to open it. So in all the coding concepts that we studied in Python till now, these are all the common errors we get. So don't worry about memorizing all of them. As you write more programs, you'll naturally become familiar with these exceptions. Now, next part is raising exceptions. So far Python has been raising exceptions automatically, but sometimes we want to create our own rules. Like for example, suppose we are creating an online banking application. So if a user enters a negative amount to deposit, we don't want the program to continue. We can manually stop that program by raising an exception using the raise keyword. But this is not already present in our above mentioned exceptions. So we will create our own exceptions here. We can manually stop that program by raising an exception using the raise keyword. In simple terms, raise allows us to create our own error messages whenever invalid data is entered. Like in many things, when we create our own things, we will have our own exceptions. There are generally these all the exceptions given here are common. These are the general exceptions, but whenever we create our own thing or some project, we'll have our own exceptions. So when we want to avoid those, then we will raise our own error messages whenever we want, and our own rules. So this helps us enforce the rules and keep our program secure. Now these are the real world applications. uh, you can check login systems, ATM software, banking, online shopping, and also user input validation. All these are the real world applications of this exception handling. It ensures that the applications continue running smoothly even when the users make the mistakes. So yeah, till now we take user input and all. What if the user make the mistake? Even then we want that application and our project to run smoothly without giving error back to back. So that's why we use this exception handling. Then okay, this is another part of our today's lecture. Okay, modules. We will learn packages and modules again, but now we'll practice questions related to the exception. Uh, like this thing, we will learn about the exception handling. So now we'll practice some questions related to exception handling about all these concepts in VS Code. So okay, here we will create our own file. For this, and for first question is write a program that takes two numbers from the user and handles the zero division error. So you have to write a program that takes two numbers from the user and handles the zero division error. Okay. Now we'll write our code. try, I'll explain the code. Int input, right, first and then second, and we'll mention second here, then the result, one more, num1 by num2, and then print result equals to the result, and we'll write the except block here. We have to write the error here also, that is zero division error. We already have this, we don't need to raise our own exception, we already have this exception here, cannot divide by 0. So here in this program we are learning one of the most common exceptions in Python, that is the zero division error. So now you can see that we use this try and except blocks. The try blocks contains a code that may generate an error. In this case we are asking the user to enter two numbers and then dividing the first number by the second number. Now imagine what if the user enters 10 and 2, then it's perfect, the division works perfectly and we'll get the answer. But what if the user enters 10 and 0? At that time, mathematically that division is not possible and Python cannot divide any number with 0. So instead of crashing the program, the Python directly jumps to this except block, and we have written specifically here that except zero division error, which means this block will execute only for a division by 0 error occurs here. So finally it prints a friendly message saying that we cannot divide it by 0. So this makes our program more user friendly because it handles the error gracefully instead of showing them a very long error message, and the user also cannot understand what is the error. So see, if I give 10 and then 2, so yeah, I will definitely get my answer. If I write some 7 and 0, see, it doesn't give any big drama of and giving all the error lines here. Instead it just gives us a short message that you cannot divide it by 0. Then the user understands and will give the good input. And then next question, handle multiple exceptions. How to handle multiple? This is the single exception, right? So have to handle the multiple exceptions, like copy, paste here. So here we have again taken this number and division and then print, but here we will take two errors, that is value error, then print please enter only numbers or integers, and one more block, except block will write that says the same block here. So just run the code and see. If I give 10 and 0, it says cannot divide by 0. And if I give some thing like star, see, it says that please enter only integers. If I say if I give any decimal, even then it says that please enter the integers only. Even for the first number itself, it says us that only enter the integers. And if we give normal numbers, then it performs the division successfully. So in this way we can handle multiple exceptions. Here we can use multiple exceptions also. Next question, else and finally. Okay, we will do the same thing. So we will just copy this code and then see two exceptions we have written here. We'll write else block, else print result equals to result. Oh yeah, here you shouldn't write this statement here. And then finally you have to write print program execution completed or program executed successfully, anything. Now if I write 10 and 20, say it says it goes to this else block and it prints that result and a result, and this block it always prints this finally block as we have studied in our slide here. So the finally prints all the time, the else prints if there is no exception, and here if we have any exception like this, see, we will get this exception and we will also get this finally block that program execution is completed. And if we have zero division error, this is not a zero division error by the way. If we give 0 here, then that is a zero division error. You cannot divide by 0, but still it gives that finally block that says program execution is completed. Now next question, handle this file not found error. Okay, that is like same. We can write try. We need to write this try first, the syntax, and then we'll use this for file not found error. We'll say some student.txt r and print file read and then file close. Except block we will write file not found error and then we'll print that file not found, simple. And then finally we'll print file operation finished. See here the file not found, it didn't give any previously. If you check that, if you check in the file handling, if you give any file which does not exist, it gives you an error. But here it doesn't throw you an error, it doesn't make drama and just throw you an error. By using this you can just find that the file not found, this exception, it prints this exception and it will print this finally statement all the time, that file operation finished. What if the file exists, like what if I give this details file? So yeah, it will print our content and again it will say that file operation finished. So that's how we use this file not found error. Then yeah, one last thing is that how to raise your custom exception. As we discussed that there will be some exception which is not already written here. How to do that? We'll just try. I'll write the code and then we'll discuss. Then raise an exception that you are not eligible to vote here, and you can just print here that you are eligible to vote. If it doesn't come under that if statement, it passes this, and except exception read as E, then we'll print this. So we'll run the code and check. If I say 17, then it says that it says that you are not eligible to vote. If I say my age is 23, then you are eligible to vote. I'll explain this code now. So in all the previous examples, Python automatically generated the exception, but sometimes we want to create our own exception based on a condition. That's where this raise keyword comes into this picture. And in this program, we first ask the user to enter their age, and then we check whether the age is less than 18. If the condition is true, then we manually raise the exception using the raise keyword. Here we are creating a general exception here, a general exception object here, and providing a custom message that is you are not eligible to vote. And as soon as the raise executes, the Python immediately stops the remaining code inside the try block, and it jumps to the except block. And we have written here that accept exception as E. Here that E that stores the exception object. We have written that exception as E, so this E stores this exception object including its message. So finally we print that message, and if the user's age is 18 or above, this exception it's not raised, and Python simply goes to that statement where we have written that you are eligible to vote, and it prints that statement. So I guess this concept is clear enough, and you understood all the concepts. This is really easy. Try, accept, and if there are some exceptions which are already there, already present, zero, division or value error or file not found error, we can use them. If not, we can also create our own exceptions. And you understood about the else and finally block also. So this concept is and by the way, this last question, this concept is extremely useful in real world applications where we need to validate user input and enforce our own business rules. So yeah, I guess you all have understood about this exception handling, file handling. We will move to our next part. క్వశ్చన్ స్టార్ట్ అయ్యే ముందు ఎక్సెప్షన్ హ్యాండ్లింగ్కి కూడా నేను ఆపేసిన. సో యా, 6 minutesకి, 10 minutesకి, 34కి, 43కి అన్నిటికీ చూసుకో అంతే. ఇంకా మనం నెక్స్ట్ ఏం చేయాలి, సర్చ్ కొట్టి ఇంకా సర్చ్ డే 8 యా. Okay, so now let's move to our final topic of this lecture, that is modules. As programs become larger, writing everything in one file becomes very difficult. So to keep our code organized, Python allows us to divide it into multiple files and call it as modules. A module is simply a Python file that contains functions, variables and classes, anything, or not all the three, anything or which we can reuse in other programs. Like it can contain anything, functions, variables, class or anything. Instead of writing the same code again and again, we simply import the module whenever we need it. So this saves our time and make our code cleaner and easier to maintain. Python provides different ways to import the modules. The most common is this import statement. Sometimes we only need a specific function, so we can use from import. We can also give a shorter name to a module using import as also, which makes a code easier to write and read. You will see all these methods practically in VS Code again. Now we'll check these. There are hundreds of built-in modules. Some of the most useful ones are math, random, date, time, OS. We have, if you have checked before, we use this OS module. So these modules, they save us from writing the complex code ourselves. There will be already code written in there, so we can just use them. We can just use this math, random, date, time, all. So creating your own module here. Besides this built-in modules, we can also create our own modules. Suppose you have written a function to calculate the area of the different shapes. So instead of copying that function into every project, we can save it in a separate Python file. Later, we simply import that file whenever you need those functions. So this makes your projects more organized and encourages the code reusability. And packages in Python. Now you might wonder, what's the difference between a module and a package? A module, it's a single Python file, but a package, it's a folder that contains multiple related modules. Now think of it like a single book, it's a module, and a bookshelf containing many books, it's a package. So package help us organize large projects by grouping the related modules together. So that's the difference between the package and modules here. So we will do some questions, only little questions related to these modules, and how to import and how can we create our own module. We will see a single example for both, then we will end our class. So we'll switch to VS Code now. So we'll create a file here, then so here we will import math module and we will find square root, factorial and ceiling value. We'll import math and num int input, enter a number, and then print square root equals to, you can just use this function, that is square root and of that number, and then you can print the factorial using math and factorial num. And then print the ceiling value, and you have to print ceiling value using this math dot seal of that number. Now we'll run the code. We'll give some decimal number here. Okay, you can't give that because you have to provide it with your integer. So yeah, this is the ceiling value, the square root, and this is the factorial. Now if you don't include this int, and then if we give any random decimal number, then you can't find your square root of that random decimal number. So that's why you have to take the integer and then run the code, give an integer, and you'll get the square root, factorial of that, and the ceiling value. This is one type of question, importing. And then You can create your own module and you can import it also. For example, here we can create a file like this, and then here we will import, sorry, we will write our function here, that is, we'll add our add function here that returns a plus b, and then one more function multiply a b. This will return our a into b, and then we'll go back to our modules packaging file. Here we will import our calculator, and num1, that will take the first input. We will also take our second input like this, and then we will print addition equals to the calculator plus add, and num1 num2, and then we'll print multiplication, same calculator dot multiply num1 num2. We'll run this code. We'll give first number as 2, second number as 3. No attribute as add. Okay. Here we have calculator. We will rename our code actually. Here we'll write it as cal. Okay, here also it got changed automatically, but here we are getting some error. It has no attribute called add, but okay, add. Is this the error? It says that it doesn't even have an attribute called multiply also. We've taken addition and then cal del plus add, and num1 num2, calculator plus multiply num1 num2. I don't know what's the error here. So okay, the mistake was that we didn't save this file. Now we'll press command S and then we will run this code again. Now here you can check the answer. So yeah, that's the problem. So we have discussed everything in today's class. If you have any questions, any doubts, you can comment it down. If you like this video, then just like the video. If you like the content, then share it with your friends who are interested in learning Python. And that's it for today's class. We will meet in the next class and we'll discuss about OOPS in the next class, that is object oriented programming. So till then, happy coding.